Okay, so this is Psych 3280, week 9, your basis of consciousness. And this week we are going to talk about the dissociation of consciousness and attention. Okay, so before starting, let's recap what we talked in week 8. First, I introduced different aspects of attention through different kinds of the definition of attention. And in particular, I pointed out important distinctions of attention, such as bottom-up stimulus-driven component, and also top-down volitional goal-direct component of attention. And then for each of them, we can have different types of the attention based on the space or time or feature or object. And these are all operating potentially by the different thing, dependent on the different types of the neural mechanisms. And then we discussed different ways to manipulate attention. And these are the 4 paradigms, especially useful for the discussion of consciousness and attention, change and inattentional blindness, and also attentional blink and the dual task, as I showed the demonstration. And also, I talked about the neural mechanism of attention using a biased competition model, basically meaning that each of the neurons have a different receptive field, and higher level visual area have a potentially conflicting information from subsets of the neurons. And biasing signal can make one dominate over the other, like a winner-take-all kind of situation, so that the higher level neurons can potentially be responding as if that particular neuron is seeing only part of it and ignoring the other. And I also said that the source of the bias could be is likely to be frontal and also parietal areas. And I discussed Terry Moore's work on the microstimulation of frontal eye field while recording B4 neurons with overlapping receptive field. And then based on these 2 types of the neural mechanism of attention, just simply try to see whether it's possible to explain some of the attention-related blindness. And for example, these 2 types of the neural mechanism says both inhibition and also amplification of a signal with respect to the current behavioral goal. And that could be largely explained, the effects in the change blindness or inattention blindness, as I discussed. And then towards the end, I also introduced one model or theory of consciousness, explaining these attentional related blindness, global neural workspace theory. We didn't go into the detail of the theory, but potentially we will talk about it in the next weeks. And then the global workspace theory also introduced this 2x2 taxonomy of how the strengths of the top-down top-down attentional amplification and the strengths of the bottom-up stimulus result in different types of the conscious experience. Essentially, GNW says that the top-down attentional amplification is necessary for the conscious experience or conscious report. And then in this week 2, what we are going to do is to review the evidence for the different types of the dissociations between consciousness and attention. And in particular, we also discussed that whether we can pay attention to objects that we do not consciously experience. This may be a bit strange to you, but we'll see how the evidence is going to turn out. I also will discuss whether we can consciously experience something without paying attention to it. And this is also another strange kind of concept potentially for you. And we'll discuss the detail of these lines of experiment. So the learning objective of this week is to understand what are the logic and evidence of experiments which demonstrate dissociation between attention and consciousness. How do they manipulate and assess consciousness? And this is important to understand, and this is a kind of the stuff that I'm going to mainly ask in this week's lecture quiz. Also, how do they manipulate and assess attention? This is another component that I'm going to assess in the quiz. And then this week, we will not require you to read any of the reading materials. And as I said from in the last week, we are now approaching to the sort of the forefront of the consciousness research. So I just upload 2 of my previous review papers, but they are potentially advanced kind of component, and you will not need to read these. Unless you are interested in this topic as a potential honors, student next year and so on. All the quiz materials can be answered if you understand the contents of this lecture. Okay. Let's start. So the starting point of our discussion about attention and consciousness is this diagram. And if you remember, this is a diagram explaining the Blindsight patients' behavior. Blindsight paper we discussed a couple of weeks ago. So the upshot of that Blindsight study was that Blindsight subject who report not seeing the vision, however, can locate the stimulus or move eyes towards the stimulus, may be mediated by not the standard pathway such as this. This side, the right side, is usual, healthy people's, brain's connection. Eye is located at the bottom, and then there are many branches of the subcortical pathway. And then here is a LGN, lateral geniculus nucleus, and then that projects to both V1 and V5. And then that's the sort of the standard kind of, cortical pathway, visual pathway to generate visual experience, presumably. On the other hand, the Blindsight patient has basically damage in the V1. So there's no V1, and that degrades the LGN retroactively. So we don't have much, input coming from eye to LGN to visual cortex. Instead, what is known is that the branch to go to superior colliculus and then pulvinar, that leads to these higher visual areas are still there or potentially enhanced. And these are potentially mediating all this behavior without giving rise to conscious experience. And then the one point that I need to point out here is that the superior colliculus, as well as pulvinar to some extent, is that this one is known to be involved in the attentional processing in many ways. So if you look at the superior colliculus and search for PubMed or Google Scholar, then you'll see that it is described as an area for attention. And attention in both in terms of the eye movements, overt attention, and covert shift of attention. So one possible logical, inference you can make is that maybe conscious experience is completely gone in this Blindsight people, but maybe attention is intact, or at least potential is still there. And that's the kind of the question that these researchers who studied this attention without consciousness started to pose. So one of the earliest type of this study, which asked, can attention affect on non-conscious processing, is Kentridge, Robert Kentridge, who is in the UK. And he has been publishing this line of the research for many years, roughly 20 years by now. And first, he has been studying the Blindsight patient GY for a long time. And then he combined the attention experiment on his Blindsight's blind field. And this, as you can see here, this is already an experiment 2 of this particular paper. And the experiment one basically suggests that blind sight patients can direct attention to the invisible field. But experiment 2 is much more compelling, and that's why I'm going to discuss more. So here, what Kentridge did is first to present the cue for the attention. Okay, this 2 bars that looks like a bar here, but it's a low contrast or high contrast Gaussian line kind of thing. And then, by the way, the time goes from top to bottom. So the blind subject would, blind side subject would be sitting in front of the display, and then there will be some kind of flash of the cue coming up, and then there will be a beep, auditory tone here. And then right after that, there will be either some kind of stimulus at the location that is cued by this cueing stimulus or somewhere else. Okay, and then this is a standard attentional task on its own, unless if you do it in a blind side patient. So the way he did it is the following. So first, it is a cued detection task, and Kentridge gave an instruction to this GY blind side patient. So in a way that so he already declared that target will be present only 50% of the trial. So that's indicated in the bottom of this figure here. Okay, 33% and 70% added up to 50%, and other 50% are absent. Okay, and however, we have the thing about this experiment, unlike the normal subject experiment, is that this target is going to be presented in his blind field. So he would be expected to not to see any of these targets. Okay, but he was told, GY was told that there will be a target 50% of the time, and he understands. Okay, yeah, I do this via the experiment, and then. Sorry, this is not an ROQ, but the cue, attentional cue, is valid in showing the location of this target, roughly at 67% of the time. But he also was told that cue will not be visible, so he may see it, but it's likely to be presented in the location of his blind field, so it's not going to be visible. By the way, his blind field locates roughly like something like this. So both target and cue is not going to be visible to him. Okay, and then he was told to press the button as fast as possible. So this is a reaction time experiment, and then every time he pressed the button to report either he saw it or not, he needs to tell to the experimenter whether he saw either cue, he saw the target every trial, and then whether he saw the cue, attentional cue in every block of the experiment. So that's the sort of the setup of this experiment. And here is the result, and this is a very complicated diagram, so I will go through one by one. So x-axis is first of all, it's a block number. One block is composed of 40 to 50 trials or something like that. And then y-axis is reaction time on this side, and then also it's a double y-axis. Correct discrimination is on this side. And then black and gray dot here, these are the reaction time measure. So what you can see here is that the invalid or valid trials make a difference in terms of reaction time. So the cue, when the cue is preceded at the location of the target, it's the valid trials, and the valid reaction time is faster. And the invalid trials, that cue is presented on the opposite location of the actual target, it's longer. So that's a nice attentional kind of manipulation and assessment. And then in terms of this two white circle and the white square here, these are the awareness or consciousness measurement. And this refers to only this right side, these are on this y-axis, correct discrimination, meaning that it's roughly like 70% of the trials. The location, the report of the detection is 70% correct, regardless of the location of the cues. So just to recap, first of all, GY, the blind side subject, never reported in this particular experiment seeing the target on each trial. And also, he also denied seeing the cues on every block. After the every block, Kentridge made sure that, did you see anything like in a cue? And then he said, no, no, no. Okay. So in terms of consciousness, GY did not see both cue and also target. That's one point. Next point is that GY was always above chance around here, above chance in terms of 50% of chance is the, target detection. And he is roughly 70% correct in a localization of target, okay? So he was able to say that, detect the target localization, quite well above chance. And also importantly, there was no difference in terms of QA. So here it is an sort of a replication of the standard Blindsight result. And then finally, important thing is this, reaction time was faster for the Q target. Okay, so this is the summary of the result per se. Let me unpack and recap this important result. Okay, first, GY, the blind sight patient, denied seeing both attentional cues and targets for the detection. And what he said here is, quote, I just listen for the beep and press a button. So as I explained to you, the experiment goes like this. And remember, and also try to imagine what it's like to be in a GY situation. You don't see things on the top right field of the vision. And suddenly, something is flashed, which is Q, but you don't see it. And then you hear the auditory tone to say that, there will be some target happening in your, again, invisible field 50% of the time. And then you are shown this, invisible thing. And then because the auditory tone says that, I need to respond, okay, I say yes or no, I saw it, and then say that, it was in here or there, even though I don't see it at all as a blind, sight patient. But somehow they are just correct, which is very, very weird. And he knows that he's a blind sight patient and so on, but that's how he describes his experience. And then the detection performance itself is above chance and doesn't depend on the attention. So this part is a replication of the standard blind sight behavior, okay? And then what's important for the attentional literature, attentional consciousness, is that the bottom-up attention was spatially withdrawn by the invisible cues to facilitate the processing of the stimulus to hasten the reaction time over there. So this is one of the first demonstration of attention without consciousness. Okay, so here is in a sense of the beginning of the literature trying to dissociate attention and the consciousness, and it was important. That's why I went into the detail. But one important question to stop here is that is this an isolated and strange finding confined in a blind sight? And we are going to take a look at the evidence in the healthy subjects in the next. All right, so next we are going to talk about attention without consciousness evidence in healthy normal subjects. So first experiment I'm going to talk about is this study by Loftkirch, published in 2012. So it's a relatively recent study. And here what they did was asking people to do the visual search, okay? So the subject's task is to look for this object. It's called a Gabor patch in study of psychophysics. It's oriented, black and gray, gray-white kind of, stripe in one of the location of this patch. But one important thing of this, visual search experiment is to make this target actually invisible to the subject, which sounds really strange, but it's possible to do. So the way they did it was to use this continuous flash suppression method that I discovered when I was a grad student, and then discussed a little bit in a couple of weeks ago. So here they present the stimulus to one eye, typically here non-dominant eye, maybe most of the time left eye for most of you, and then project a different stimulus to the dominant eye, right eye, using the mirrors. Let's say if you have an filter for red and green, like 3D theater like situation and so on, you can do something like this. And then in particular, what they did was for presenting this target for 1 second, but at the same time, for this 1 second of the time, they presented what's called Mondrian mask. That is a high contrast and edge rich and colorful and so on to the dominant eye. Then as a result of this, flashing of this, each of the stimulus, usually this is flashed at every 100 milliseconds or so. So over one second, you see tens of the patterns like this, which is completely random. And then most likely the dominant eye and its corresponding retinal neuron and LGN and B1 neurons responding to the input from dominant eye gets activated every time there is this new input coming in. It can create a very effective suppression, flash-induced suppression on this side, and that's why it's called continuous flash suppression. And all you see consciously is this one, okay? And then you can imagine that you are asked to search for this Gabo pattern, but because of this flashing thing, you just can't see it. And that's a really weird kind of situation, but this is similar to the situation of the blindsight patient. They say that, oh, I don't see it, but you are, as an experiment, you ask them, there will be some stimulus and you try to look for it, or just respond as fast as you can. And then if you are still a subject, you are like, yeah, okay, I'll try. But most of the time you just don't see it, okay? So that's how they did this experiment. And then after that 1 second elapsed, they presented this random pattern to both eyes to remove the possibility of the after image. And then right after each trial, they asked subject to do the for 0.5 seconds there is a blank, and then after that they asked where was a pattern or not. So it's like a detection kind of response. And then how sure are you, coming from, the confidence rating from 1 to 4. And then after that, they ask also which spatial location or spatial orientation. In this case, it is to the right oriented or left oriented Gabor patch they need to report. Okay, so, and then these 3 questions are the assessment of conscious experience, basically. Then what they found was that they looked at so by the way, it is very important to say that during this experiment, subjects were also monitored in their eye movements. So not only this, complicated, left and right eye separate stimulation, they also recorded eye movements where the subject is actually looking at very carefully. And then by doing so, they were able to find that even though they don't see it, these targets or not, when they separated the trial into the stimulus area versus control area, and then they found that the percentage of the time that your eyes are around the location of the target is significantly higher than the location where you don't have the target. Of course, if this is completely visible situation, then the dwell time would be like 100% for the stimulus area and 0% for the control area, most likely. However, because this is an invisible situation and all you see is this flickering pattern, it's still surprising that your eyes go to the target, in fact. And then, so this is a measurement of the attention, okay, or proxy of the attentional processing. On the other hand, the 3 questions that they asked using this, analyzing all the trials in which participants were very unsure regarding the stimulus location. So this is based on the confidence rating after each trial. They looked at that, and then location and orientation discrimination was at chance level, 50% as a chance, okay, around 50%. So in terms of conscious experience or conscious reports, they just can't tell where the things are or what kind of things they were, but your eyes kind of knew it. So that's the sort of the surprise of this experiment. And this was published in Current Biology, one of the highest journals in the field. And this is quite a convincing demonstration that attentional or eye movement kind of processing can happen without conscious experience. So what does this mean? And the first thing is that subjects try to search for a target on the CFS, meaning that it's this invisible target. Okay, and in trial, subject denies seeing conscious stimulus. Still, attentional measure, eyes movement are going there. So this case is that overt spatial attention equal eye movements were guided towards the target based on this invisible target. And also, it is also important to note that this is there is some kind of parallel, potential parallel with the Blindsight situation. Not only the phenomenology, but also potential anatomy. This is again coming back to the diagram of the Blindsight explanation. But you know that even within this healthy subject anatomical schema here, superior colliculus is here, and then goes to pulvinar, and then goes to B5 or other higher areas, and that part is more the same with Blindsight patient, right? So it is plausible that using continuous flash suppression, we can knock out the process around here within the normal subject, and then induce the residual function of the superior colliculus or pulvinar to higher visual areas, and that is especially effective in terms of driving overt eye movements or covert shift of attention, and it demonstrates attention without consciousness. So next, the last demonstration in the normal subject is at the level of behavior using the verbal reports and also detection task, as well as eye movements during the visual search. And now we wanted to look at what's a possible neural mechanism, looking at the neuroimaging technique, functional MRI. So here, Bahadur Barami, in use at the time England, did the following experiment. So this one again used a continuous flash suppression, and then and it was published in 2007. So it was right 2 years after we published CFS paper. So what he did was, again, he presented dominant and also non-dominant eye, different type of the image. Okay, and then the first thing to note is that continuous flash suppression happens on these 4 quadrants. Okay, and then it's again flashed at 100 milliseconds or something like that. And then subject basically sees only these, meaningless patterns, edge-rich, contrast high patterns. And then to the non-dominant eye, corresponding location, including this part and then this part, had done line drawings of the objects. And then this was, although you may not see anything here, top right and the bottom left, it is actually a scrambled version of the line drawing is presented here. So that the hope is that amount of the lines or contrast is more or less equated with respect to these line drawings, so that at least early visual areas would be activated more or less equally. Okay, and then the as I said, the conscious perception wise, what you see is to the right side, but your right eye and the left eye sees completely different things. And then up to V1 layer 4, these are, the left side is definitely processed, and after that there is some kind of suppression going on, and then you don't see it. Okay. And then the other important component of this experiment is this attentional manipulation. So as you can see in the center of the display, to the both eyes, they presented this letter, roughly 1 degree, letter. It's, as the size of your fingernail at the arm's length. And this changes in its color and also the identity over the time, like this way, W, N, T, Z, Z, T, W, and so on. Okay. And then what Bahadur did is to ask subjects to report or count the number of the occurrence of the target during this fMRI experiment. So here, the low load condition corresponds to, in this case, subject actually press a button, sorry. And then whenever they found the letter T, regardless of whether it is black or white. So it's a low load task because you don't need to pay attention to the conjunction of the feature between the color and the letter identity. So regardless of the letter, whenever they see the T, then they just press a button. Okay, it's relatively easy, as you will see. On the other hand, in the high load situation, Bahadur asked people to respond either white N, like this, or black Z. And the white N and Z are rotation, sort of, symmetric. So it's you need to pay special attention to make a conjunction response. It is a demanding task in a sense. Okay. So that's attentional manipulation. Okay. And then what they found. First, all of these experiments is important to verify from the behavioral manipulation. So the location accuracy wise. So they asked subjects to see whether the stimulus, the invisible target object was on the top right, bottom left pair, or top left, bottom right pair. It's always either of the two. And then regardless of the attentional load manipulation, subjects were at chance, 50% correct in these, two alternative post choice. Okay. And then, so that's a sort of consciousness manipulation check. And also CFS is relatively reliable, so, they believe this thing. And then the secondary, the reaction time. So when the target appears at the center, they press the button and as fast as possible. And under the low load, regardless of the color, if it's T detection, then it's 580 milliseconds. Under the high load, Z black or white, N, it's much slower, 640 milliseconds. So this again, behaviorally ensures that subjects were paying attention to the central task in this condition, but they didn't need to pay attention to the central, or at least there were 660 milliseconds of attention-free kind of period during this consecutive fMRI experiment. Now, the upshot of this experiment is of course fMRI response, and here they localize the neural response within V1. It's called a retinotopic mapping technique, and then they looked at the brain response, neural response only at the location of these 4 patches. Okay, and then what they found was that compared to this standard scrambled location, the intact object location produces stronger response, and stronger especially when the attention is more available to spread to this invisible object. Okay, so this is the measure of the neural activity. This is a conscious experience. This is an attentional check. Okay, what they found was the neural activity to the invisible stimulus increased when the attention is more available to spill over. Okay, But when the attention is confined at the center, they couldn't. And the evoked response by the invisible object was much, much smaller. So just to recap, what does this mean? It means that under the CFS, first participants could not tell the difference in the object location, either this or that. So they didn't see it, only saw that Mondrian patterns. And then attention load was manipulated tightly by the central task, and then they confirmed it by the reaction time. Okay, and then V1 activity, that's a neuronal measure, is higher under the low load condition. So that means that attentional amplification of the signal happened on the things that they do not see consciously. So again, this is another instance of the attention without consciousness. So just to recap, under the low load, special attention may have spilled over the invisible stimuli, enhancing neural activity. Okay, but here, important thing to notice is that attention was not sufficient for visibility. So what does this mean? Okay, now we are going to come to a summary of this old literature. But before going there, just briefly, this evidence for attention without consciousness is quite large, in fact. And here's the list of the things up to like 2013, and it's all further growing, in fact. And we reviewed this Kentridge's the first paper, and then Baharami's study, fMRI study, and so Rothkirch today. But in fact, I talked about Montezer-Kozari's result using this crowding stimulus, these things, and the adaptation experiment. And there, what Montezer-Kozari found was that the adaptation, unconscious, adaptation induced by the crowding, requires attentional amplification. So that's also one, example of the attention without consciousness. And Rothkirch, the Kaunitz here, is also similar motion based adaptation. When it's complex type of the motion after effect, even though you suppress it and then you see the effect, you need to pay attention to the invisible thing to get the after effects. So that's the growing evidence for this attention without consciousness. So about the attention without consciousness, there is a growing evidence, and now we are seeing more and so more and more. And just to recap, inspired by initial Blindsight findings and now mostly established. And however, you need to stop and think about whether it makes sense conceptually and also philosophically. Some philosophers seems to still have some program, or at least revise or revisit some of the assumptions of all these experiments. In fact, you need to think, what does it mean to attend to something that is not consciously experienced? Is the mode of attention completely different or not? And to do that sort of the conceptual exercise, we'll revisit models of the relationship between attention and the consciousness, introduced in week 8. So first of all, Victor Lame reviewed some of the claim that makes serial architecture of attention and consciousness. Here, the class C is the sort of summary of the class A and B, making the claim that whatever stimulus input is first filtered by both attention and consciousness, and only attended one gets reported here. Okay, and then another one is that first you see things consciously or not, and then only those what you see can be attended or not. And then what you attend in the end becomes consciously reported. But both of them seems, at least insufficient to explain some of the finding that I showed, right? Because what we found was that, this unattended component of the things, it's not really consciously reported. So in that sense, it's not super inconsistent, but the nature of the unattended stimulus is not considered here. It's just stopped there. And here is the more problematic assumptions that only consciously experiencing can be attended. That seems unlikely to be true, because here these unconscious invisible things can be also attended, but there is no pathway for this unconscious attention here. So one way to revise this type of the thinking is to have an following revised serial model. First, things gets either attended or unattended, and then among the attended ones, subset goes to conscious and the subset goes remains unconscious. Okay, then the other non-serial model proposes something like this. That is that whatever the input comes, it's either focally attended and then becomes consciously reported or not. And here, attention equal consciousness, and that also seems to be inconsistent, because what you're attending is in fact not sufficient for consciousness. So there are subsets. I don't know whether Victor intended this part is the unconsciously remaining unconscious, but attended kind of things, but something like that, attended but not sufficiently strong enough or whatever to become conscious is not described in this diagram. And then finally, this dissociation model is the more intuitive or directly correspond, consistent with the finding. Here is that the focus of attention can operate on both conscious and unconscious processing, and this is a part that we are talking about, right? Attention does not really guarantee that you become conscious of the stimulus. However, the neuronal activity or behavior can get improved or emphasized. So that's one consistent conceptual model of attention and consciousness. So in sum, what I tried to say was that the attentional amplification can occur independent of the consciousness. And then that poses the next question. Does amplification of the neural activity explain what we consciously experience? So this may require a bit of the stopping for your thinking. Typically, many people assume that the stronger activity, sustained activity, or whatever happening in the brain is sufficient, and also what is what we experience. But is it really the case? That's the question. So if it turns out that attentional amplification amplifies many signals really sufficient degree, but does not guarantee conscious experience, it can mean that attentional amplification or amplification of a neural activity is not sufficient for conscious experience. And one possibility to think about this type of the framework is that stronger neural activity is necessary for a report. And that seems much more reasonable, because in the end, when you try to report by a button press above a report, it needs to reach to some motor area or executive area. And then that one gets reported through behavior, right? And however, if you introspect yourself, whatever you experience, not all of them are going to be reported. So what you see, what you tend to see as an enhanced or amplified activity may be corresponding to what you can report about it, but not really related to what you are experiencing. And this distinction between experience and report is going to be something that we will discuss for the next 2 weeks as well, final 2 weeks. And then finally, neural mechanisms for attention and consciousness are unlikely to be totally overlapping. At least, this mechanism seems to suggest, for example, through sphere colliculus and fulvinar, maybe there is a facilitatory mechanism in operation, which is completely independent of of how we consciously experience. And what are they is going to be the next question. So the question before the next video is that even if attentional amplification is not sufficient for consciousness, is it still necessary? Okay. So this necessity and sufficiency kind of condition is a bit complicated, but what it means is that whatever you can consciously experience, it must somehow amplified by attention. That's the question. If it's not, then is there any evidence to suggest that attentional amplification is not necessary for consciousness? That's the question next, and we'll review some of the evidence. Okay, so the next part, we're going to discuss whether attentional amplification is always necessary for consciousness. And this part of the topic is one of the most controversial topics in the current consciousness research. So my sort of the standpoint is that it is not always necessary for consciousness, but other researchers say different things. And I'll just declare that my the point is like that, and also the questions and the quiz for this week is based on the factual sort of the knowledge about the lecture contents, not the opinions or the sort of the belief about these things. Okay. So here's the first sort of the recap of what I discussed a couple of last week. So according to the global neural network space theory, stimulus has to be sufficiently strong to activate these posterior or occipital brain areas for the visual areas. Otherwise, this neuronal activation is too weak to propagate. And then also top-down attention has to amplify these signals to make it pass to the prefrontal areas or parietal areas and so on to eventually achieve this conscious reportability. Otherwise, it is confined within these occipital temporal areas and then do not get reported. Okay, no reportability. Reportable is quite difficult things to do. We just cannot report, okay? Even though if it can be experienced. The question is, what is an ideal method to study possibility of necessity of attentional amplification for conscious perception? So in week 8, I discussed, I suggested a couple of methodology. So in week 8, I overviewed a couple of methodologies, including inattentional and change blindness, as well as attentional blink. And then these experiments tend to be interpreted as a necessity of attention. So unless you attend to, you do not even see a gorilla that goes across the display. And another one is that even if there is a change, unless you attend to, you do not perceive the big change that you cannot help seeing after once you notice it. Okay. However, in these experiments or experimental paradigm, it's not that easy to interpret these experimental result as a pure necessity of attentional amplification, because as I explained in this bias competition model or of the neuronal circuit, attention is always on one side it is a selection and the amplification of one thing, and the another one is the inhibition of unwanted stimulus. So both in attentional and the change blindness situation, you might argue that we do not experience like gorilla or small changes in the change blindness because we actively suppress it through attentional inhibition. And if that's the case, then the argument about necessity of attentional amplification is not that easy to establish. So that's one of the problem. And then the other issue is that in both in attentional and change blindness, stimulus manipulation is also limited. It's a very interesting paradigm, but for example, to make the gorilla invisible, you need to have a setup where the transparent, people are passing the basketball, and then people are paying attention to the white team and then suppressing a black gorilla kind of thing. And it's not that easy to change all these things into, many different kinds of color or, spatial arrangement or dynamics and so on. And also change blindness wise, it's very interesting to generate the surprising kind of, stimulus sets, such as the background of the face in the $20 bills changes from blackish to, whitish kind of color. But it's not that easy to make any kind of a stimulus set in a systematic manner. And most likely, the contextual effect or expectation or expertise also make a difference for these things. So as an upshot, it is not that easy to manipulate attention and also conscious experience in an orthogonal manner in these things. Having said that, I'm not saying that it's not impossible. It's one of the active areas of the research, and it would be nice, honors project type questions, in fact. So instead of this inattentional blindness or change blindness, this week I'm going to focus more on what we learned from the dual tasks. And dual task is also something that I described in week 8, but this week it's going to be in a more detailed manner. So just to recap, in a dual task situation, we present some stimulus. First, it starts with a fixation, and then ask people to perform very demanding tasks such as letter task here. So we tend to present the stimulus like 5 stimulus, rotated T's or L's, and then ask them either all L's or all T's, or one audible included. So in this case, one L is included among T's. So you need to press a button for the different, not the same. Okay, and then the difficulty of this central task is individually calibrated, which is very important, by masking the stimulus with a rotated Fs. And the rotated Fs have a common feature as Ls and Ts, so it's very effective in terms of the masking stimulus. And in the previous study, it has been established that doing this task at the center, letter task, exhausts almost all the attention. What it means is that if you have another task that seems to require attention, you just can't do both at the same time. And therefore, using this in the logic, people have tried to present some other stimulus, in this case, picture of the natural scene masked by natural scene mask, and then ask people to do a task on that. And then idea is that if the peripheral task requires substantial attention, then trying to do that peripheral task degrades that task performance of the center. And then you cannot do that simultaneously, both central and peripheral tasks. And that's the logic of this dual task. Okay. And as a upshot of this dual task paradigm is the following diagram. So x-axis is usually the performance of the primary task. Here, let's say, it's an LT task, with a L, all the L's, or, one T, included kind of thing. So this is a different situation, and this is the same situation, all L's or one T included. And then it goes from 0.5 chance performance to something like 0.7 or 0.8, depending on the study, some kind of threshold, very difficult level of the task difficulty. And then that's controlled by the duration of the stimulus, or SOA, stimulus onset asynchrony. And then you do the same thing for the secondary task, okay? So the secondary task is also going from 0.5 to, let's say, 0.7 or 0.8, accuracy. It's very difficult. You set the mask performance, mask duration to be as difficult as the primary task as well. Okay. So this is a typical mistake that many people make. So both primary and the secondary task has to be equally difficult, or equal performance on its own. So the task performance result cannot be explained by the difficulty of the task itself. Okay, this is something that I'm going to ask in the quiz. However, what we are interested in this dual task situation is that the trade-off of the task performance between the two tasks. If this primary task and the secondary task is drawing the same kind of resource, or competing for neuronal resource or whatever, then the trying to keep the performance of the secondary task will degrade the primary task performance. So that when you plot both secondary and primary and secondary task performance together, then it locates here. And then if you prioritize the primary task, it locates here. And then this diagonal line corresponds to the perfect trade-off between the two situations. On the other hand, if there is no trade-off, then each of the tasks can be performed perfectly on its own, but perfect in the sense of 0.7%, 0.7 accuracy, or 70% accuracy, and also 70% accuracy, because both of them are made difficult on its own. But it doesn't interfere or interact in either way. And that corresponds to this top right location of this dual task performance. Here, X coordinate indicates a performance of the primary task, and the Y coordinate implies the performance of the secondary task. Okay, and both of them are not different from the single task performance of this guy and this guy. And then, as I said, if there is a complete trade-off, there can depending on the task instruction, like if you are asked to prioritize a primary task a lot, then it should locate somewhere towards bottom right. And then if you are asked to prioritize secondary task, it should locate somewhere here. But the important thing is that this diagonal line connecting the two single task performance should predict the two task performance. Okay. And then finally, there is also a possible situation where the task performance of the two draws as partially attention requirement, and that corresponds to anywhere in between the top right and the diagonal. That's an intermediate situation. Okay, so these are, roughly speaking, 3 different outcomes of the dual task situation. And before going into the result, I just want to discuss these advantages of the dual task paradigm when you consider the consciousness and attention. A consciousness without attention situation, right? Or asking this, if it's possible or not. And the first is dual task can minimize a stimulus interaction between the fovea and the periphery. So it can study one stimulus property at a time. And this is quite unlike the change in blindness. So what I mean, you can present a foveal letter task at within the 1.5 degree or even smaller location, so that your central spatial attention is presumably sucked up to this location. And then you can present the peripheral stimulus far away from here. And then at the periphery, we can ask whether this peripheral stimulus requires also attention or not, but without having to consider this interaction of the stimulus location. When the stimulus is very close to each other, I mentioned in a couple of weeks ago in a week 6 and so on, there is an effect called crowding, right? So if you are fixating at the center, and then if you are trying to look at, let's say, orientation of these 3 things, the central thing becomes very difficult to see if it's surrounded by some other things. However, if it's on its own, it's easy to see. And this phenomenon crowding is also known to interact with attention. But what we are interested in the pure sort of the effect of the attentional amplification. Is it necessary for consciousness? So we wanted, at some case at least, we want to minimize this kind of crowding like effects, and then just purely look at attentional requirement or trade-off between the two tasks. And dual task can do it, but change blindness is not possible to do it, because change blindness does require some kind of complicated stimulus manipulation to achieve this distraction or misdirection of the expectation. Okay, so that's one advantage of the dual task. And then the second advantage of the dual task is this. We can separate the effects of expectation, or memory, or attention from separate expectation and memory from the effect of the attention on consciousness. And this is very difficult to do with inattentional blindness or change blindness again. If you remember, inattentional blindness, you are expecting you're focusing on the task of this counting the basketball, right, of the white team. And you're not expecting the gorilla to walk in. And if you're expecting it, you can actually see it. And this expectation and attention seems very similar, but there isn't also ongoing research showing that the expectation and attention is probably very different in terms of neural activity. Our own result seems to suggest that our expectation operates much, much earlier in terms of sort of, in terms of metaphor, you are going to open or close the door to the entrance of your house. That's the sort of expectation. If you expect things, you open it, but if you do not expect it, you close it. And then attention is more to do with how you treat this, guest that came inside of the house. Attention would be like, attentional enhancement is something like, after a guest is coming inside of the house, you treat them really well, and then, sort of amplify it inside the house. So this expectation and attention is likely to be different in terms of operation and also processing wise as well. But change blindness and inattention blindness is manipulating attention through the expectation. So it's very difficult to dissociate these things. And also memory is also tricky in attentional blindness or change blindness. Because here, what I mean is that when you say that inattentionally things are invisible, it's also plausible that because you do not pay attention, you forget quickly. But this is not the same as you don't attend to things and you do not experience it, right? So, for example, if I tell you like random numbers 4, 5, 7, 6, like 1, 7, 2, 10, 5, 2, 11, and things like that, then unless you have a really good memory, you do not remember everything. And as a subsequent report, you just can't report all these numbers. But that's not the same as you did not experience all these numbers. You just forget really quickly. Similarly, in attention blindness and change blindness literature, it's not clear still at this point whether people are experiencing things and then just quickly forgetting it. And forgetting speed could be different for different feature of the stimulus. So that's one possible viable explanation, but it's very difficult to also test with this. But now, with the dual task experiment, we can try to separate all these expectation and the memory from attentional effects. And we are going to discuss about these issues in the later weeks. Okay, so now the disadvantage of the dual task problem. So first of all, you might imagine also that doing the two things at the same time requires some kind of training. And in fact, it is the case. In the lab, if you try to ask people to do it, people can do it or not. There's a huge variability in terms of the individual difference, but that's usually because of the training or prior exposure to the dual tasking itself. But once people are trained, then this kind of dual tasking, multitasking kind of capability saturates really quickly, and then we can test this, attentional task requirement. However, to get to this stable level of the training, previous dual task paradigm has used something like sometimes 10 hours or 12 hours of the training, because even within 1 hour of the training, people do improve. It's called perceptual learning. And because of this, training related improvement, and because you want to measure the performance at both center only and peripheral only and the dual task, people have been very careful not to test a subject before the training finishes. But this comes across as a sort of the cost of doing this, detailed dual task paradigm. Of course, it takes time. It means that it is both human and also actual money-wise, it's costly. And also, more important and tricky thing about consciousness is that doing a lot of training makes a circuit of the brain potentially completely altered. And some of the things that you do really well, like riding a bicycle or writing letters and things like that, you do feel like you do it in a non-conscious manner. And in fact, all these practice very well trained task performance is known to work without conscious experience. And that's potentially because it is sort of the performed now in different parts of the brain, like in the cerebellum and so on. That is not to do with the consciousness. But anyway, the important disadvantage of the previous dual task paradigm is that lengthy training is necessary, but the lengthy training might make the performance non-conscious manner. And another important thing is that in the previous dual task paradigm was impossible to rule out the possibility that attention itself spills over to the stimulus during the dual task. So as the Bahadur-Bahrami's fMRI task proved, the low cognitive demand task, which does not require a lot of attention to the central task, seems to make it possible to spill over in terms of attentional amplification of the peripheral task. So it is very difficult to rule out the possibility that when you find some evidence that we can perform the task under the dual task, you just can't say that we can consciously see that without any attention. It is still like requiring some kind of attentional amplification, but it's logically very difficult to argue whether it is yes or not. Okay. So my previous student, now currently postdoc in Japan, Riken, Julian Matthews, resolved some of these issues, at least to some extent. The first issue of the lengthy training is quite a bit shortened, and also ruling out the non-conscious processing is also achieved because of the shortened, lengthy training, as well as combining it with the measure of the metacognitive accuracy. Previously, all the dual tasks just measure the performance without any metacognitive accuracy. So it wasn't clear whether the people were doing it unconsciously or consciously, but now we have measure to do that. So here's the recap of the demonstration of our version of the task 2018. At the center, you see that there's a letter briefly flashed, and here it's all else and masked by F, and then followed by the response screen. Here comes one T included and the masked by F. So that's a first response, same or different with a different level of confidence. Okay, it was the same and then confidence 3 and so on. And then at the same time, what you see is that in the periphery we present faces, and the faces is either male or female. Okay. So that was a female, and all throughout the task, you are asked to fixate at the center, okay? So you do not move your eyes, and then you still say that it was a male and so on. And then importantly, as you remember, that the speed of the masking for both central tasks, for the L or T's with the F, or mask for the face, you see the jumbled or scrambled texture pattern followed by each of the face is adjusted so that each individual subject can perform these tasks at 70% accuracy. And then the question is, what happens if you do both at the same time with minimum training? Okay, it's a bit complicated, but that's the sort of the experimental paradigm. And then this is the control experiment, or equally important experiment that we did. So here it is a peripheral task is now changed into the discrimination of the red to the right side on the green to the left side of that type of the disk, or green on the right and then the left type of the disk. Okay, and then you do basically the same kind of experiment. And again, similar to the face task, red-green task is also equated in terms of 70% accuracy. Okay, so all of the three tasks, central, peripheral face, and the peripheral red-green task is always equally difficult at the 70% when you do the task on its own in a single task situation. Okay. And the first improvement that Julian achieved is to use the calibration procedure called the Quest, which is a detail that I'm not going to detail, can reduce the duration of the training quite a bit. So this pie chart shows that the previously shown this 2004 paper required like 10 to 12 hours or 6 to 12 hours of training before going into the main task, but now we shorten it into the 10, 15 minutes of the training. That's a substantial improvement, important not only for the, in terms of the cost, but also removing the possibility that, we are doing this task automatically, non-consciously in a zombie manner, okay? And this is first to show that, the original ready experiments, result. As I said, the dual task performance is usually presented in this format. So here, what you see is that the central performance is on the x-axis, starting from 50% as a sort of the chance performance, and then 100% is a perfect. And then, for example, this person DS performed a single task at the 75% or something like that, 78%. And then peripheral task performance, in this case, it's a face gender discrimination, is roughly 70%. So everybody has a baseline 70%, the single task performance for both central letter task and the peripheral face task, okay? And then each of them had lots of trial and lots of blocks, and then measure the mean location of the dual task. And here it's a mean location of the dual task performance for each individual subject, okay? And then usually dual task result is also presented in a way that, to make it easier to understand, x-axis and the y-axis is normalized to 100% being the same as a single task performance. And then here's the format, which is easier to understand. So normalized performance is being 100%, and normalized performance being for the periphery, 100%. These 6 subjects located pretty much at the top right, meaning that the face task, face gender discrimination task, and the letter discrimination task at the center does not interfere each other. And because the letter task consumes pretty much all the attention, you can conclude that, face gender discrimination task does not require attentional resource, even though it is equally difficult. And on the other hand, this the red-green disk task was completely at chance when they performed it in a dual task situation. So this means that red-green task does require attention to get the 70% performance. Again, I just say that the x-axis is always normalized, okay? Y-axis is normalized. So 100 corresponds to 70% and so on. And both tasks face gender discrimination, and these tasks are equally difficult at 70% when it's performed as a single task. However, as I mentioned, previous experiment could be explained by, okay, so face task is something that you do non-consciously, even though without attention. That's why you don't see the deficit. That's the possible explanation, especially because of the 6 to 12 hours of training. However, when the Julian did the experiment with a very short training, just 15 minutes of the experiment, basically we replicated this result. For the faces, we see the trade-off to be almost like zero, right? Trade-off line is this diagonal. On the other hand, this disk task is almost diagonal. It's very it again replicated that disk or center task can be performed but not at the same time. So that's the first replication. And then the second component is that we added this confidence rating for each trial. And now with this, we can measure this metacognitive accuracy. And this is something that I explained in a week 4 or so. And then just to recap, in addition to the type 1 discrimination, where you present either face or non-face here, signal or noise, and then correctness of the decision itself, face or whether the task was whether the trial was correct or incorrect, and then assumption here is that the confidence rating should be high for correct trials and low for incorrect trials if you know what you are doing. And that's sort of one of the operational definition of the conscious access of the discrimination. And then in the case of the blind side people, I showed that blind side people can have a performance around here, meaning that it's a much above performance. But when you use this type of the type 2 task, making confidence rating after his own performance, then he tend to locate at this chance performance, metacognitive accuracy. So in the case of the blind side or continuous flash suppression in a normal healthy subject, type 2 is always likely to be around the chance, but type 1 can be above chance. That's the point. And then we applied this technique for our face task. So here's the result. So before going into the type 2 analysis, first we want to show the confidence rating. This x-axis and y-axis is a confidence rating for the central task and the peripheral task. In the case of face, when subjects are correct, then their confidence rating is higher than incorrect. Okay, for both central task and also peripheral task. And then for both dual task as well, when the task was correct, then the confidence rating was high. But if it was incorrect, then the confidence rating was low. So there is an metacognitive access to whether you are correct or incorrect. But interestingly, this disk task situation, central task itself is same in terms of the confidence rating as expected here, and the peripheral task is also the same. When you are correct, they are higher in terms of confidence rating. But when they perform the 2 tasks at the same time, in terms of the central task, central correct or central incorrect can be differentiated by cognitively, metacognitively. However, the peripheral red-green, whether it's correct or incorrect, it becomes completely impossible to discriminate whether it was correct or not by the confidence. And that results in this pattern of the type 2 performance, showing here that, in the case of the face, it drops compared to the perfect situation, but it's definitely above chance metacognition. But in the case of the disk, it completely collapses. So, because the performance itself is bad in the dual task situation, well, it's not a huge wonder, but we made sure that, our subject cannot also metacognitively access to this, information. And then this, just briefly, this green and the blue dot. So this is to rule out the possibility of this inattentional amnesia. In all of these dual task situation, we ask 2 responses per trial. In this green dot, the task was to report either central letters or peripheral disk, and we did not ask 2 at the same time. And so it's really unlikely that people forget about the response, but still, we couldn't rescue the performance in any case. Okay, so from this, we can conclude that this disorientation is not something that is, inattentionally forgot, but it's more likely that it is inattentionally blinded. So finally, to rule out the spillover of the spatial attention, we did one of the experiments. It's not the perfect kind of a control experiment, but I think still it's very interesting. We asked what happens if we merge face and the disk at the same time, like this way. Okay, we carefully calibrated the transparency of the disk and the face for each individual subject, and then achieve again the performance to be roughly 80% correct for both face task and also disk task, as well as central task. Okay, around 80. Triangle is always single task performance. However, in each trial or in each block, we asked either to report at the central letter and the face, which resulted in this excellent dual task performance, or central letter and disk, which is here. And this means that one particular object that is composed of the face and color disk, some aspect gets lost by distracting the subjects by the central task, but some property remains, meaning that in this particular case, it's a face gender impression remains, whereas the disk color orientation relationship just becomes inaccessible if you do the attentional task. It's very difficult to imagine why this is the case, but if you become a subject of our experiment, you can experience by yourself. All the subjects reports that when you are doing a central task, you can still see the face gender, but you just can't see this color, subjectively speaking. And in terms of the metacognition, it's basically replicating the first experiment. So we can say that face discrimination is supported by the metacognitive axis. So it was a bit in detail, but it was important kind of experiment. To summarize, the dual task paradigm has revealed that some stimuli, namely face, gender, are consciously experienced with which is verified by the metacognitive accuracy without top-down attentional amplifications, without sort of qualification, but the same level of the top-down attentional amplification applied to the disk is definitely not possible to raise it into the conscious experience, but for some reason face gender you don't need that kind of amplification. But then the straightforward answer is that why do the effects of withdrawing top-down attention differ depending on the stimulus or task? That's the next question. And in fact, when we reviewed the literature of the dual task situation, the pattern of the results is not that straightforward. So the top row here is the ones the combination of the discrimination that does not require attention. But at that time of the review, 2015, none of the this condition was measured with metacognition. So we do not know 100% sure that whether they are consciously perceived or just non-consciously performed above chance. But anyway, the simple feature of the color or color orientation conjunction or orientation itself, or letters, if it's applied or not, if it's applied, T versus L, and then the natural scene, including animals or not, or face gender. These, you just can do it without attentional amplification. And then the pattern of the result is like, here, always, no dual task interference. And then these 5 things, red, green disk, or rotated letters or symbols in between, or the orientation of the rotation of the dots, or the lightening condition of the cube. All of these are the ones that require top-down attention. So these would fall into somewhere around here or here, this trade-off line. And you might have some kind of ideas of what makes it possible to perform without attention, and what makes it possible impossible. One possibility is that these faces and natural scenes and the upright T and L's are in a sense complex but overlearned training stimuli, and maybe we have brain areas that are dedicated for each of them, and the local circuitry does not require any kind of attentional amplification. And these fundamental sort of the simplistic features are also like that. We also have a dedicated kind of circuit, and we don't need any attentional amplification. On the other hand, all these things in the bottom row may be something that is first of all, it's an arbitrary combination of these features, right? It's an artificial kind of things, and so brain may need to bind these features artificially, attentionally to experience it, and that may be the reason first. And secondary, red-green case is in particular so, but maybe it is a local neuronal circuitry is interfering each other in some particular way, so that to resolve some kind of competition, like biased competition model, you need to have an attention to resolve these local circuit computation and to perceive it. But this is not known. It's a sort of frontiers of the consciousness research, and great for the honors project. Okay, so the question still remains, and one thing is that can we push the dual task paradigm further? And particular questions could be something like what about the other stimuli and tasks, such as different modality of the tasks. One of the students in our lab, Sharon Danielle, is asking whether we can find something like this in the tactile modality, and so far the answer seems to be no. And another possibility is the auditory stimuli, and so on. This is not asked before, because partly because of the training of the dual task took really long time, but now we can make it much shorter. The second big question is that whether we can do this kind of task online. It still is very difficult to do, but if we can establish an online protocol of the dual task, then it's plausible to test many different kind of different combination of the stimuli and the tasks, and then see sort of we can map out what is the possible without attention, and what requires attention. We just need to know more about this taxonomy. And then, as I mentioned briefly, manipulation of the expectation and memory, separating it from attention, that's also possible, but not so many people have done so far. Our partial report paradigm with Julian is probably the first thing to be reported. And then also the mechanism of underlying these distinct psychological components are still unclear. using EEG or fMRI to understand, what makes it possible to do the task, in parallel, and what makes it impossible without such attentional amplification. It's unclear still at the level of the neurons. And then finally, the simple-minded activation equal consciousness model still maintainable or sustainable? That's the sort of theoretical kind of question. So this is one possible, model or sort of default kind of people's expectation about, conscious and non-conscious stimulus. Maybe there is some kind of threshold here, and conscious stimulus can be just, attended or unattended, just can, go over to this, threshold, and then that's when, you start to see the things, and that could be the case of the face, gender discrimination. On the other hand, this unconscious stimulus could be that, or artificial stimulus that has something like this, red-green thing. If you are not attending, then you just can't, go over this threshold. But if you attend to it, it goes over the threshold. That's one kind of a default sort of the threshold or activation amount equal to consciousness kind of model. But I would say that this type of the model is just unsustainable and inconsistent with many for many reasons. Okay. And first of all, it just doesn't explain anything about why particular qualia, like visual qualia, coming out from visual cortex. All these activation and threshold type explanation, including the global workspace theories, explanation, should operate, everywhere, right? Like not only visual, but auditory cortex and olfactory, cortex and touch cortex and so on. Everywhere, it operates. But our experience generated by the visual cortex and the temporal cortex for sound is very different. Why is that? And secondly, that we even within the visual cortex, why do neurons in the fusiform area, when stimulated, elicit this face percept, like I showed in a couple of weeks ago, but the same kind of neurons close to each other in a B4, B8 area elicits color. That's really weird, and this activation consciousness model will never get to that kind of question. Now comes sort of the upshot of this, all these consciousness lectures actually for the last 3 weeks. What are the alternatives? Alternatives, first of all, some types of neural activation patterns must correspond to how we experience. It's not the simple activation amount. And then what kind of patterns? That's the next question. Many people have studied and proposed that it is a synchronous neuronal firing, like firing in auditory cortex and the frontal cortex simultaneously makes it possible for the auditory cortex generated sounds to reach to sort of the conscious frontal areas, something like that. Or the causal interactions. So neurons are connected to each other, and it forms a very complex network. And if the interaction achieves some types of the causal interactions, then that leads to a particular type of conscious experience. And the latter is something much closer to what I've been thinking about. And this is most clearly proposed by a particular theory called the integrated information theory of consciousness. And this is the theory that I'm going to explain next week and following week as well. And this is again forefront of the consciousness research, and it is also fairly controversial. Okay, that's it for this week. See you next week.